We have three physical states: solid, liquid, and gas. What's the difference between these three states? Let's think about it in terms of the shape, the volume, and the attraction or movement of these particles in the different states. Let's first talk about the state of solid. And a prime example here is a piece of rock. Looking at a piece of rock, you may not know this, but the atoms are very tightly packed together. They have high attraction to each other, and because of this high attractions, they are not moving much. Even with a lot of energy, the only thing they can do is vibrate. Because of this lack of movement and high attraction to one another, the shape of solids do not change. They have a definite shape. Sure, when you break a rock, that piece of solid may shatter and become more pieces of solids, but you don't see it flowing from one shape to another. And for sure, the volume of a solid does not change. And now transition and think about liquids. Now in a liquid, the particles now have more energy to move about than they do in the solids. They have more energy, but still the attraction between the molecules are still very great to keep them together. So the particles are still close together. So between this balance is the reason why the shape is whatever its container is in. You can almost imagine this like a bunch of ants. Have you ever seen ants hanging on to one another? Imagine water molecules or other compounds the same way in its liquid state. They're still attracted to each other, so they're clinging on to each other, but not so much that they can't move. They can still move about each other, changing shape. But even in that movement of changing shape, they do not change its volume. Imagine water. When you pour water into a glass, the gravity pulls some water molecules down. At the same time, the water is attracted to other water molecules clinging onto one another. Once it settles into the glass, it spreads out and has that new shape, but still contains that volume. Now, when we move on to gases, it's totally different. In gases, particles move very fast. They have a lot of energy, and because they are moving very fast with high energy, they may break the attraction between each other and be very far apart. And that is why the gas has no definite shape. It takes the shape of whatever container it is in. If it is in a balloon, it takes the shape of a balloon. If it is in a tank, it takes the shape of a tank. If it is released into the atmosphere, it takes the shape of the entire atmosphere. It also fills the volume of whatever container the volume has. And that's why gases can be compressed. It has so much space that you can push them closer and closer together in a smaller space. To summarize the states of matter, I like to give you a molecular perspective of what we just discussed. If you go to fed.colorado.edu, you can see a simulation of the states of matter in its molecular view. So for example, we have here, I've chosen oxygen. So in its solid state, at negative 242 degrees Celsius, it holds its shape. Even with gravity, this does not flow down into its container. It holds a shape of a solid. And you see how it's vibrating? This is to signify that there is some energy in there, and the molecules are moving. We do not see it from our eyes, of course. This is at the molecular perspective. Now when you go to liquid, it starts to kind of flatten out into the container that it is in. You can see that the molecules are still attracted to one another. You don't ever see one molecule just floating around somewhere else. Now if we give it more energy by increasing the heat here, you will be able to break away from this attraction from each other and giving you the gas phase. And in the gas phase, the molecules are really far apart from one another. Now let's look at another molecule that we are familiar with. Let's go with water. In the gas phase, water is moving all about, filling this whole container with water molecules. Now this is moving a lot faster than the oxygen example because our temperature here is very high. What does water look like when it's a liquid? The water molecules now are condensed down and they are attracted to one another. They are very close to one another. They do take the shape of their container. What about the solid? Now in a solid, the molecules are not moving as quickly. Okay, so you can play around with that more if you like.